Hello everyone. Today we're going to talk about something called the discriminant. Now be careful, we're not discriminating, we're going to be discriminating. So just be careful. Okay, so the discriminant is b squared minus 4ac. Now, you're probably getting a little bit of deja vu because you probably have seen something with a b squared minus 4ac. So I'm going to go back. Well, actually, hold on. So b squared minus 4ac. If you think back to when we learned about the quadratic formula, do you see a b squared minus 4ac? Holy hot dog, I see it too, you guys. Do you see underneath the radical we have b squared minus 4ac? Okay, so that part of your formula is called the discriminant. Now, the discriminant is very important because what it lets you do, it lets you know in advance how many solutions you're going to end up with and the types of solutions. So if they're like real or imaginary or rational or irrational. Okay, so you can kind of be like a math magician. You can already know how many and what kinds of solutions you're going to get for your quadratic by just solving the discriminant. Now, the discriminant doesn't actually allow you to solve your equation, but it just gives you some helpful information, and you'll know some things about your solutions before you're done solving, which is pretty cool. Okay, so there's different cases for what type of discriminant you get, and then what types and numbers of solutions you'll get for your quadratic. So, remember, the discriminant is what is underneath the radical. So you need to think about your answer being what you get underneath the radical. Okay, so if your discriminant, which is the D, if your discriminant is greater than 0, and it's a perfect square, so let's say you get something like 4 underneath your square root. Well, the square root of 4 is a perfect square, and the square root of 4 is 2. So you're going to get like something plus 2 over something, and then something minus 2 over some other number. Okay, so you're going to end up with a rational answer, which means your answer can be represented with a fraction, and it means you'll end up with 2 solutions, because you're going to have a number plus 2 divided by something, and a number minus 2 over something. Okay, so you'll end up with 2 real rational roots if the discriminant is positive and it's a perfect square. Okay, so that means your graph is going to hit the x-axis or smack the x-axis 2 times. Okay, and it's going to hit the x-axis at a rational number, so something like 2 and negative 4, for example. Now, let's say that your discriminant is still positive. So regardless, you guys, if your discriminant is positive, you will end up with 2 real solutions. Okay, if the discriminant is a perfect square, that's when you end up with rational roots. If your discriminant is not a perfect square, like over here, if you get the square root of 13 underneath your radical, well, you can't simplify that down. So that means your answer is going to have like the square root of 13 in it. Okay, so if you end up with a positive value for the discriminant and it's not a perfect square, you will end up with 2 irrational roots. So your graph will still hit the x-axis in 2 spots. It's just going to hit some number that's not like a pretty whole number. It'll be like some long decimal or like something under the square root. Okay, now let's say that the number under the radical or your discriminant is 0. Okay, so 0 is underneath the radical. Okay, so the square root of 0 is 0. So if 0 is under your square root, you're going to have like negative b plus 0 over something and negative b minus 0 over something. Now, if you add or subtract 0 to a number, like if you do like 1 plus 0, it's 1. And if you do 1 minus 0, it's also 1. Okay, so if you end up with 0 as your discriminant, that means you're going to end up with 0 under the square root. And the square root of 0 is 0. So this means that you're going to end up with a repeating 0, or something called a double root. So like I told you, you could get 1 plus 0, which is 1, or 1 minus 0, which is also 1. So you're going to get like the same answer 2 times. So if your discriminant is 0, you know that you'll have 1 real rational root. So you're going to end up with 1 solution. Technically, it does count as 2 zeros still. It's called a double zero. But since you only get 1 number twice, it will count just as one solution. So you get one real rational solution. Okay, and whenever you have a double root, what the graph does, it will hit the x-axis once, and it will kind of like bounce off of the 0. Do you guys see how it like comes down? It's like boing, it bounces off. It's kind of like there's like a little springboard right here. Okay, so if you ever have a double root, that's how your graph will behave at the 0. It won't like cross on through like the graph is doing up here. And when the graph is bouncing off of your 0, that is called being tangent at the 0. That's the proper way to say it. Okay, and finally, if your discriminant is less than 0, what types of numbers are less than 0? Yes, they are negative numbers. So if you end up with a negative number under a square root, because the discriminant, remember, is under the square root. Okay, so if you end up with a negative value for your discriminant, that means you have a negative number under your square root. And what types of numbers appear, or what types of numbers do you have if you have negatives underneath your square root? That would be an imaginary answer, or a complex root. So if you end up with a negative number as your discriminant, you will have a negative sign under your square root, which means you're going to have two complex roots, or two imaginary roots. Okay, so something like 2 plus 3i and 2 minus 3i. Now, imaginary numbers do not appear on the regular coordinate grid system. So if you end up with imaginary zeros, that means that you have zeros, but we can't see it on this graph. So that means your graph is not going to cross the x-axis. If you have a real 0, it will hit the x-axis, like in these first two. If you have an imaginary 0, it will never hit the x-axis. So it will either like hover above the axis or hover below. That's what your graph will look like, which is kind of neat. Okay, so knowing all that, what we're going to be doing in example 1, 2, and 3, we're going to find the discriminant, and then based on what the discriminant is, we're going to list the types of roots, so if they're real or complex, and then the number of roots, so if we have one root or two roots, basically. Okay, well, let's get started on example 1. I'm going to go back to here because this will be helpful in a little bit. Okay, so example 1. Okay, so we have the discriminant, which is b squared minus 4ac. Okay, which you can't see it again. Rats. Hold on. Let's see. Come on, thing. Don't do this to me. Sorry, guys. It's freezing again. Okay, let's see if I can fix it. Please work. Come on, guys, we gotta give it good vibes. Work, please. Okay, it's working now. Okay, sorry about that, you guys. But anyways, so the discriminant is b squared minus 4ac, and again, that is the portion underneath the square root in your quadratic formula. So the discriminant doesn't have a square root, but when we think about the discriminant, we always want to think about what it would look like underneath the radical. And that will kind of help you decide how many and the types of roots that you're going to get. Okay, well, let's get started. So we're going to list the numbers and types of roots. So example 1, our quadratic equation is x squared minus 4x minus 5 equals 0. And in all three of these will all equal 0. So we don't have to worry about making one side 0 first. Otherwise, we would need to make sure that this side is 0. Okay, so the first step, since the discriminant has b's, a's, and c's in it, it would be helpful to know what the a, b, and c are. So let's identify those real quickly. So a is the number in front of the x squared, which currently I don't see anything, which means there's secretly a 1 out in front. Okay, so my a is 1. My b is the number in front of x, which is negative 4. And my c is negative 5, the number without the x. Okay, so now I'm going to calculate b squared minus 4ac. So my b term is negative 4, so negative 4 squared minus 4 times a, which is 1, times c, which is -5. Alright, let's start simplifying. So -4 squared, or -4 times -4, is positive 16. And then -4 times 1 times -5. Well, -4 times 1 is -4. And -4 times -5 is positive 20. Okay, and then 16 plus 20 will give us 36. Okay, so our discriminant is 36. Okay, so our discriminant, which I'm going to represent with, well, I'll just write discriminant. I won't be lazy this time. So discriminant is 36, and 36 is greater than 0. So our discriminant is greater than 0. Also, our discriminant is a perfect square. If I were to put that under a square root, we can take the square root of a 36. The square root of 36 is going to be 6. Okay, so knowing that, let's look at our little cheat sheet real quickly. So if we end up with a perfect square, which we did, and a positive discriminant, that means we're going to end up with 2 real rational roots. So that would simply be my answer. So my final answer, the discriminant tells me I'm going to end up with 2 real rational roots. And guess what? That's it, you guys. So we're going to find the discriminant, and using that information, we can determine how many and the types of roots your quadratic will have. Cool beans.